Hi, my name is Ned. I work in business intelligence and I'm a Microsoft MVP with a focus on Power BI. And this video is going to be all about data quality. And that's because it's a walkthrough of a solution that I've been working on in the background for quite some time now. It's meant to solve one singular problem. And that problem is data not tying across multiple reports and semantic models. And this solution that I'm about to walk you through is completely built and runs natively in Microsoft Fabric because it's just basically a bunch of Python notebooks. That said, because this video is going to be a technical walkthrough, it might not be the most interesting thing in the world. However, I would encourage you to watch it all the way through if you're interested in data quality and implementing a data quality system, so you can see how I've implemented this system. And if you don't want to implement this exact one, you can start to design one of your own. So with that out of the way, before we jump on into the computer and I start babbling on about Python notebooks, if you could do me a favor and give this video a thumbs up and subscribe, it would mean a lot. Okay, now let's jump to the computer. So we're going to start off this video in the GitHub repo that contains all of the Fabric notebooks that make up, and I quote, this data quality validation system. And I admit that that sounds a little pretentious for a bunch of Microsoft Fabric notebooks, but I don't know how else to describe this a little bit better. And the reason why we're going to do that is because there's some pretty nice graphs that we can kind of walk through the process a bit easier with in this repo. Okay, the first graph is a high-level system overview as to how it works, or like what we're trying to accomplish. Essentially, you have a bunch of semantic models in your tenant, and those semantic models might contain the same KPIs but named slightly differently or filtered slightly differently, and you want them to start tying. You want them to start producing the same result. So what you can do is you can write a DAX query that should produce the same result against all of those various semantic models, and put that DAX query into what are called checks. And those checks are run by a single data validation job. And we'll get into checks a little bit more a little later on in the video. But that validation job essentially reads and writes to Lakehouse tables. And then you can query the results of running all those checks into a Power BI report, or you can rerun specific checks on demand. So you can either run a check every single time a new semantic model is deployed, or for example, you could rerun all failed checks. Now, if you can't tell by how many times I've said the word checks, this whole thing is completely dependent on checks. And what are checks? Well, checks are essentially a data validation rule. You can have two different types of checks. You can have a static check against a static value, or you can have a model check against a DAX query for a given model. So if a specific model is a source of truth, you can validate all of the other models against a DAX query coming out of that model. You have two tables linked to checks. You have the baseline config, which is what I have open over here. And then you have a check registry. In this check registry, you have a few different columns, right? You have the check name, you have the model name, the workspace ID, the dataset ID, and then you have the DAX expression that the check is validating, a run frequency, so indicating like, hey, should this only run once a day? And also you can set a check so every single time the job runs, it runs. If it's only set once a day, it only runs once. You have a fail percentage. So what is the percentage that a check will fail at? So in this case, it's 0.3%. And then you have an indicator indicating if the check is active or if it's the baseline. So if it's the query that all of the others are being executed or checked against, right? And this piece right here matters for model-driven checks. I've said the word check a lot, but let's go look at a diagram and hopefully that helps you understand how this works. First, you start a check for a given run. So like, right, you start either my first check or my second check. It determines the baseline mode. So is it a check against a model, right? In which case it will resolve the active baseline row and then execute the DAX, or it'll be static, in which case it'll read the static baseline value. Then it will loop through all of the models for that given check name. So a given check name in the example I just showed was my first check. It will execute the DAX expression. It will get a value. It will compute a delta versus the baseline value. It will see if it passed the check, and then it will write either a pass if it did pass, a fail if it didn't pass, or an error if it ran into a DAX error or connectivity error, for example. So enough reviewing documentation. Let's actually start to set this thing up. I have it fully set up and working in this workspace here called Validate that is assigned to a Fabric capacity. In this workspace, I have created a lakehouse called Data. The first thing that I needed to do in Data is I needed to go into the files, create a folder called code, and then in code, copy in the config Python file. Now this config Python file contains some details around the environment, so the lakehouse name, and then the schema name that we want to create these tables in, some default ready and validation settings for the DAX. So for example, how many times it'll ready, how long it'll wait before readying again, and then how long it'll wait until for the DAX query to execute before it times out. It will then indicate also table maintenance, so like an optimize and a vacuum. And right now it's set to run on the 6th day of the week. Today is Monday, so it is currently the 1st day of the week. And then it has the actual like full computed schema. This config Python file is really important because all of the notebooks reference this. That way you only have to really input in variables once. Although one thing you'll see throughout these notebooks is if they can't find this file, they do all have fallback variables set. Okay, the next thing that you need to do is you need to run the data quality setup notebook. Now, what this notebook does is, and by the way, for all these notebooks, you need to make sure that your lakehouse is added and connected to them. But the first thing it does is it goes and it fetches those default variables. Then it creates the tables that you actually need. It verifies the tables have been created. And then the other thing that it does is it also creates some delta column defaults. So it adds a bunch of defaults onto the tables and alters them. I would recommend running this piece so that way you don't get a bunch of null values populating into your tables, but I think technically it is optional. Okay, the next thing that we have is we have the actual like check setup notebook. Now this is an add or update notebook, which means it essentially uses an upsert to either create a new check or modify a existing check. And it does that upsert based off of the check name, the workspace ID, and the dataset ID. The model name, workspace name, and dataset name, you can actually kind of set to anything you want because it really references the workspace ID and the dataset ID. But those are just in there in case the workspace name or the dataset name evolves over time. Then you have a DAX expression. Now this expression is required irregardless if it's a static check or a model check. If it's a model check, this is the expression that will be used to configure the baseline. And if it's a static check, this expression will be evaluated against the static value, right? Then you have a once a day or multiple times a day. Once a day, it will only run once when the job runs. And even if you rerun the job notebook, it will continue running. Multiple times a day, it will run every single time the job notebook runs. Then we have the fail percentage. If the check is active, if the check is baseline, the check type, so model or static. And then if it's static, you are required to give it a baseline value. Just as a side note, you can reassign which model is the baseline, which is why this is available in the upsert notebook here. But you can only ever have one baseline at a time. And if you try to delete the baseline, it won't let you using the delete a check notebook, which we'll get to a little later on. Once this runs, it runs some validations and then it creates the check and it verifies it. Then we have a smoke test notebook, which essentially just validates that, hey, the data structure and everything you've created is not going to blow up when you try to run the job. So whenever you create a check, it's probably a good idea just to run this, just to make sure that nothing's going on. Then finally, we have notebook 4, which is the actual notebook that you would schedule to run all of these checks all at once. And in this notebook, it evaluates the check, right? It will rerun any once a day check with an error status. And then it actually executes the check to see if they pass or if they fail, and then creates a nice little summary. Finally, this is also where the table maintenance is. Again, if it's the weekday where the table maintenance is scheduled, it will start to run table maintenance. So that would be optimizing and vacuuming and then computing core statistics. Finally, then we have some optional notebooks that help you run through some of this kind of stuff. So we have the rerun check. So this is kind of irregardless of the status of the prior check. You can take a check, like for example here, I created a check with the name of my first check and I reran it for all models, all data sets, all workspaces, and it went through and it reran it. So every single time I run this, it will rerun that check, right? And so see here, the check passed without an error message. And then we have a notebook to rerun just the failed checks. So this would be, the reason why you would want this one instead of just rerunning the job is, let's just say you wouldn't want to run the checks that can execute multiple times a day. You just want to run the failures. So it simply looks for failures, identifies a failure, and then it reruns the failure to make sure it passes. And then our final one is our delete a data quality check. Now you have 3 types of deletes that you can execute. You have where you can delete a check in total, right? So that would be just like, hey, the check named my first check, I want to delete all of them. You can give it a optional workspace and data set to just delete that section of the check. So like say, hey, I just want to remove this workspace and data set. And then you also can have a hard versus a soft delete mode for any of these. And if it's a soft delete mode, it just sets is active to false, in which case the job notebook won't pick it up every single time. And then finally, we have some sample Power BI queries in case you're wanting to build out a data set. So with that, you've reached the end of this video. If you want to use anything that I just showed you, it's all available completely for free, linked down below in my GitHub. You can download it, you can modify it, you can do whatever you want. And if you enjoyed this content and enjoyed talking about data quality, especially in Microsoft Power BI and Fabric, why don't you go ahead and subscribe? Because I make a lot of videos about cool technical topics just like this one. So with that, I'll see you in the next video. And yeah, give this a thumbs up or something. Talk to you later.